Hi dear students, how are you? I hope all are fine. Okay, today let me discuss about quantum numbers. Before going to quantum numbers, first have to recall Schrodinger wave equation. Okay, see, Schrodinger wave equation is dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square plus 8 pi square m by h square into e minus v into psi is equal to 0. Okay, now if you derive this Schrodinger wave equation, then we will get some solutions. Okay, then it will give quantum numbers. The solutions can give quantum numbers. Okay, see, now Schrodinger wave equation gives mainly principal quantum number and azimuthal quantum number and magnetic quantum number. Okay, but Schrodinger wave equation didn't give spin quantum number. Okay, we got principal quantum number, azimuthal quantum number, magnetic quantum number from Schrodinger wave equation, but spin quantum number we didn't get from Schrodinger wave equation. This point I have to remember properly. Okay, next, quantum numbers. How many quantum numbers are there? There are 4 quantum numbers. What are they? First one is principal quantum number. It was denoted by small n. Azimuthal quantum number, it was denoted by small l. It is also called orbital quantum number or secondary quantum number or angular momentum quantum number or subsidiary quantum number. Okay, now third quantum number is magnetic quantum number. It was denoted by m suffix l, ml. Now fourth quantum number is spin quantum number. It was denoted by m suffix s, ms. Okay, now here actually what is the definition for quantum numbers? To understand the definition for quantum numbers, first let me explain one small example. Okay, see, now one person is there in the world. Okay, now I want to find that person exact location. Okay, for that purpose I want some things. What are they? First I want his country name, after I want his state name, after I want his district name, after I want his mandalam of city or village name. Okay, after I want door number or phone number, after I will meet the person. So for meeting a person, a particular person in the world, we want some things. Okay, like this only. Similarly, to locate the electron in the atom, I mean address of electron in an atom, we want some things. Okay, those are called quantum numbers. Have you understood about quantum numbers? Definition: simply, quantum numbers, by using quantum numbers, we can locate the electron in the atom. These are called quantum numbers. Okay, they are 4 quantum numbers. Now see, actually we know in the atom there are shells or orbits. Now in the orbits or shells there are subshells. In the subshells there are orbitals. In the orbitals there are electrons. This point I have to remember. First atom, in that atom shells or orbits, in that shells or orbit subshells, in that subshells orbitals, in that orbitals electrons will be there. Okay, this point I have to remember. And now here see, what is the use of principal quantum number? Principal quantum number will give the information about size and energy of the shell or orbit. Okay, now secondary quantum number or azimuthal quantum number can give information about shape of the subshell. Now magnetic quantum number can give information about orientation of orbitals in the space. Okay, next, spin quantum number can give spinning of an electron in an atom. Have you understood? Simply, principal quantum number can say about shell or orbit, azimuthal quantum number can say about subshells, magnetic quantum number can say about orbitals, spin quantum number can say about electron. Have you understood? Now let me discuss one quantum number clearly. Now first let me start principal quantum number. Okay, now let me discuss the first quantum number, that is principal quantum number. Okay, see, principal quantum number was proposed by Niels Bohr, the scientist Niels Bohr. It was denoted by small n. The values are 1 to infinity, 1 2 3 4 5 and so on infinity. Okay, next, it represents the size and energy of the shell or orbit. This is important, I have to see. Okay, by using principal quantum number we can know the size and energy of the shell or orbit. Okay, next, here n value shell number. Now if the n value is 1, then it is K shell, n value 2, L shell, n value 3, M shell, n value 4, N shell, n value 5, O shell, n value 6, P shell, and so on etc. up to infinity. Okay, see, now this is the atom. In this atom, it is first shell, second shell, third shell, fourth shell, K shell, L shell, M shell, N shell. Okay, now here if n increases, if the n value increases, 1, 2, 3, 4, 5 and so on increases, then the distance of this shell from the nucleus also increases. Then if n value increases, and again energy of the shell also increases. Simply if n value increases, the energy of the shell increases. Okay, this point I have to remember, very important. If n value increases, then energy of the cell also increases. What is the order? Now K shell have less energy, L shell have more energy than the K shell, M shell have more energy than the L shell, N shell have more energy than the M shell. Now the order is K is less than, L is less than, M is less than N shell and so on etc. Okay, this is the order. This energy order I have to remember. Shell energy order remember properly. Next, the maximum number of electrons in an orbit is given by the formula 2n square. Here n in the sense orbit or shell number. Total number of orbitals in an atom is given by n square. Here n in the sense orbit or shell number. Now angular momentum of an electron in an orbit is given by the formula mvr is equal to nh by 2 pi. Okay, this is simply about principal quantum number. Okay, principal quantum number will give information about size and energy of the shell or orbit. Have you understood? Okay, now let me discuss the second quantum number, that is Azimuthal quantum number. Okay, see, Azimuthal quantum number was proposed by the scientist Sommerfeld. It was denoted by small letter L. The values of L depends on n principal quantum number. That is L is equal to 0, 1, 2 and so on n minus 1, or L values is equal to 0 to n minus 1. Remember. Next, it represents about the shape of the subcells SPDF and so on etc. And it gives angular momentum of electron. The formula is h by 2 pi root over L into L plus 1. Here h in the sense Planck's constant, L in the sense Azimuthal quantum number. Okay. Next, see, the energy of subcells in the same cells order is S less than P less than D less than F and so on etc. This also you have to remember. The maximum number of electrons present in the subcells is given by the formula 2 into 2L plus 1, or it is also equal to 4L plus 2. Okay. Next, this table you have to see subcells, L values, electrons. Subcells SPDF, G and so on, still so many are there. Here L value, see, for S orbital L values 0, P orbital 1, D orbital 2, F orbital 3, G orbital 4. Now here by using this formula I have to calculate. In the place of L I have to substitute 0. Then what you will get for S orbital? In S orbital how many electrons will be? See, 0, 4 into 0 plus 2. How many 2? Now P orbital 1. Here I have to substitute 4 into 1 plus 2, 6. D 2, L value 2. Then here I have to substitute 4 into 2, 8 plus 2, 10. F here I have to substitute L value 3. Here I have to substitute 4 into 3, 12 plus 2, 14. Next G, 4 I have to substitute here, 4 into 4, 16 plus 2, 18. Okay, this table I have to remember. Now this table let me discuss. What is this table? N values, L values, subcells. Now N value is 1, I mean it is K shell. L value 0, remember. Subshell 1s subshell will be. Okay. Now N value 2, second shell, L shell. Two subcells are there in that. Okay, L value is 0, 1. What are the two subcells? 2s, 2p. Okay, next third shell, I mean M shell. L value is 0, 1, 2. Three subcells are there. What are they? 3s, 3p, 3d. Now fourth shell, I mean N shell. Here L value is 0, 1, 2, 3. What are here 4 subcells are there. What are they? 4s, 4p, 4d, 4f. Okay. This is simply about Azimuthal quantum number. Remember properly. Have you understood? Okay. Now let me explain the third quantum number, that is magnetic quantum number. Okay. See, it was proposed by the scientist Lande. It was generated by ml or m. Now it explains the Zeeman effect and Stark effect. What is Zeeman effect? Zeeman effect in the sense the splitting of spectral lines under the magnetic field is called Zeeman effect. And what is Stark effect? Stark effect in the sense the splitting of spectral lines under the electric field is called Stark effect. Now we can know about Zeeman effect and Stark effect by using magnetic quantum number. Okay. See next, the values of m depends on L. L means angular momentum quantum number. That is ml is equal to minus L and so on 0 and so on plus L. It means minus L to 0 to plus L, or otherwise one formula is there, ml is equal to 2L plus 1. Here L in the sense angular momentum quantum number. Now the total number of m values indicates the total number of orbitals in the subshells. This is very important. Total number of m values indicates total number of orbitals in the subshell. Remember. Next, it indicates the orientation of orbitals in the space. Okay, this is the main use of magnetic quantum number. Again, see next examples. Let me discuss, then we will understand. For S subshell, now I want to calculate m value. So for that purpose, L is equal to 0 for S subshell. ML is equal to 2L plus 1. Now here L value I have to substitute. 2 into 0 plus 1, it is equal to 1. It means answer is 1, but value is 0. Okay, it means in S subshell, the one orbital is there. Okay, that orbital value is 0, but answer is 1 here. Remember, this is very important. Answer is 1, but value is 0. Okay, next for P subshell, L is equal to 1, ML is equal to 2L plus 1. For P subshell, L value 1. Okay, now in this formula I have to substitute L value, then 2 into 1 plus 1, it means 3. Answer is 3, but values are minus 1, 0 plus 1. Okay, answer is 3, but values are minus 1, 0 plus 1. They are orientations, orientation values, minus 1, 0 plus 1. Now it means, what is the meaning? P subshell have 3 orbitals. What are they? Px, Py, Pz. Their orientations are minus 1, 0 plus 1. Okay, next for D subshell, L value 2. Now ML is equal to 2L plus 1. Okay, now here L value I have to substitute, then 2 into 2 plus 1, it is equal to 5. Okay, now here answer is 5, but values are minus 2, minus 1, 0, plus 1, plus 2. These are the orientation values. It means in D subshell there are 5 orbitals. What are they? dxy, dyz, dzx, dx square minus y square, dz square. Now their orientations are minus 2, minus 1, 0, plus 1, plus 2. Okay, here remember answer is 5, but values are different, minus 2, minus 1, 0, plus 1, plus 2. This is very important. Next, let me discuss about this table, then you will understand clearly. Here subshells. So what are the subshells? S, P, D, F, G, H and so on etc. Now L values. What are the L values? See, S subshell L value 0, P 1, D 2, F 3, G 4, H 5. Okay, now number of orbitals in subshells is given by the formula 2L plus 1. In the subshells, how many orbitals are there? We can calculate by using 2L plus 1 formula. See, now here for S subshell, I want to calculate number of orbitals, then formula is 2L plus 1. Now here in the place of L, I have to substitute 0. Then 2 into 0 plus 1, it means 1. It means in the S subshell, how many orbitals are there? One orbital is there. Okay, next number of electrons in the subshells is given by the formula 2 into 2L plus 1, or it is equal to 4L plus 2. Now here L value we know already, L value is 0 for S subshell. This L value I have to substitute here, 4 into 0 plus 2, it means 2. Now in the S subshell, how many electrons are there? 2 electrons are there. Now say in the same way, in P subshell, L value 1 and number of orbitals 3 and number of electrons 6. In D subshell, L value is 2, number of orbitals 5, number of electrons 10. In F subshell, L value 3, number of orbitals 7 and number of electrons in the F subshell is 14. And next in G subshell, L value is 4, number of orbitals is 9, number of electrons is 18. Next in H subshell, L value 5, number of orbitals 11, number of electrons 22. Have you understood? This is simply about magnetic quantum number. Okay. Okay, see, next quantum number let me discuss, that is spin quantum number. It was proposed by the scientists Goudsmith and Ulenbeck. Okay. Next, it was denoted by ms. Values are ms is equal to plus of, minus of. Here plus of is for clockwise direction electron spin Here minus of is for anti-clockwise direction electron spin. Next see, it was indicated the direction of spin of the electron. This is very important. This is the main use of spin quantum number. Next see, spin angular momentum of the electron is equal to h by 2 pi root over s into s plus 1. Here s is equal to total spin. Next, the maximum number of electrons in an orbital is equal to 2. For example, this is the one of the orbital. In this orbital 2 electrons can fill. Here first electron have clockwise spin. Here second electron have anti-clockwise spin. It can rotate to the clockwise direction. It can rotate to the anti-clockwise direction. Plus of, minus of. Okay. This is simply about spin quantum number. Have you understood? Okay. Now let me give one example regarding all quantum numbers. Then you will understand clearly. See, the question is write the 4 quantum numbers for last electron of sodium. Sodium atomic number how much? Atomic number 11. Okay, symbol is Na, in the sense natrium. Latin name is natrium. Okay, its electronic configuration is 1s2, 2s2, 2p6, 3s1. Now they are asking how to write the 4 quantum numbers for last electron of sodium. 3s1 electron. For 3s1 electron, you have to write 4 quantum numbers. See, n value, L value, I mean principal quantum number, azimuthal quantum number, magnetic quantum number, spin quantum number, I have to write for the last electron of sodium. Now I want to write n value. N value how much here? It is ns. N value is 3. Okay. Next L value for s orbital 0. Already we know. L value for s orbital 0. L value for p orbital 1. L value for d orbital 2. L value for f orbital 3. This you have to remember properly. Okay. Next ml values. Formula is there. What is the formula? 2l plus 1. Now here L value 0, 0 I have to substitute, 2 into 0 plus 1, it means 1. Now answer is 1 but value is 0, it means, here see, it is S, 3S, value is 0, okay, but answer is 1, this point I have to remember, don't forget. Next MS value, this electron is clockwise direction electron, okay, it will rotate to the clockwise direction, so the spin is plus of. Now what are the values? Here n is equal to 3, L is equal to 0, ML is equal to 0, MS is equal to plus of. Okay, have you understood? Okay, this is today's class. If you like this video, then press the like button and please subscribe my channel. Thank you. All the best.